Okay, so hello to our Python for data analysis course. And in this first lesson, which is the basic one, we are going to install a very important distribution, which name is Anaconda. Now, I don't know if you're familiar with that bundle of packages and softwares that data scientists or data analysts use, but is by far the #1 distribution that all of the people in the realm of data science or data analysis uses. Now, of course, to say the least, there are still several percentage of all the people who are in the community of data which still uses R, which is another data friendly language that mainly came from the academic realm. We are not going to talk about anything that is related to R because we are focusing on Python. Having said that, just know that in Anaconda, there is an option to install an editor, which is a software that enables you to write software in R. But I'm only going to present this ability. I am not going deep into how exactly you're going to be using R in R Studio, which is the editor that I just mentioned. So when we get there, I will remind you that I've talked about it. But back to the main thing, Anaconda. Okay, so Anaconda, as I've said before, is a bundle of packages which are basically wrapped segments, snippets of code that other people in the community have wrote. They are all being clunched together to a single bundle with extra softwares which enables you to write code. Now, we're going to cover several kind of softwares that enables you to write code, and I will say very briefly exactly what are the softwares that are suitable for specific commands and what are softwares that are more fit for other uses. So, how do you install Anaconda? It doesn't matter if you have a Linux operation system, a Mac, or a PC. You can still go to any browser that you use. You can write Anaconda. Soon you will get to the website. And in the website, you go to products, and then you choose individual edition. Now, Anaconda is an open source platform, but you can still have several products that are enabling you to have assistance from Anaconda personnel. Now, we are not going to talk about that, just see that you have different products here. We're going to be talking about it, the individual edition, which is the open source distribution of Anaconda. Now, open source means that anybody can use it to any purpose, beside the purpose of selling it as is and as your own product. So mainly the thing is you can be downloading an open source platform such as Anaconda or any package that Anaconda automatically installs on your computer and sell it as your own. That's a violation of the open source license. So if you want to get into the details of what exactly is the license, you can dig in here and you can find exactly what are the things that you are eligible to do and what are the things that you are not eligible to do. But back to the main thing, you press download, and here you get to links to all the executables or all the possibilities to install the software depending on your operating system. Now, I'm using a PC, so that means that I will download specifically the bundle installation that fits to my computer. And to know exactly which one of these two I need to download, I will go to, I'm using Windows 10, so I will go to System, and then I will see exactly what is the system type that I've been using. So I'm 64-bit operating system, so I will press here and I will download the installation. Now, mind you that I went straight to Python 3.7 and not to Python 2.7. Now, the reason is that Python has its generations, means that Python 2.7 is an earlier version of Python as a language, as a programming language, versus Python 3.7, which is a more modern Python. Now, there are a lot of similarities between the two versions, but the main thing about version is that it is a best practice to work on a specific version when it becomes stable, which means that because this is an open source platform, if someone just released the version of, let's say Python, like the open source community of Python, send out the distribution which is newer, let's say Python 3.8. Now, because it's new and nobody has been using it, then they might have a couple of bugs, meaning they might have a couple of errors in their code. So all the new users will tell the developers that they have bugs, so the developers will need to fix those bugs, and all this feedback loop to version 3.8 will take time until all the main bugs will be fixed. So during all this time, the version is not stable enough. So people still use Python 2.7, but Python 3.7 is, for a long time now, is very, very stable. And I really advise you, if you're new to all of this usage of Anaconda and specifically Python, then download Python 3.7. Okay, don't download Python 2.7. Most of the people / companies that are downloading Python 2.7 are only doing that because they need to maintain code that the developer that was developing a software 5 years ago developed something and it was in Python 2.7 and he didn't want to rewrite it again in Python 3.7, so he needs Python 2.7 to run his code. Now, if you are writing a new software, then you don't need to download Python 2.7. So download the most stable new version that you can, which is in our case Python 3.7. So we downloaded it and then we run it. Double click it. In PC, in Mac it's the same. In Linux, depends on what kind of operating system you have, or even if you run it with a GUI. But the installation is very simple. Basically, you're just doing next and agreeing to the license agreement. Now, the install for just me or all users, depending on you, what you prefer regarding the safety of your users in your computer. So I will just go on and press the just me. Then now I suggest that you won't play with the path that Anaconda wants to install all of the bundle on. So you can click next here, but if you still want to change the path, that's fine. But you need to be careful with that because that might cause some errors regarding environmental variables that try to search where exactly Python is, and if it doesn't find it in the default place and you didn't specify exactly where the Python installment is, then that might cause errors later on. So try to be careful with that. Now, because I already have Anaconda, I just got an error that there is already a Anaconda in that path. So I will not install it. I will just add another character so we can go on and you will see the installation. Now, here in the advanced options, you have two checkboxes that you need to press on. Now, I know that you get a message that is not recommended, but I suggest that you do check this checkbox because This will automatically add the path to the Python from the path that you install Python, actually whole Anaconda to, into those environmental variables that I talked about earlier. So I suggest that you will check this checkbox and you run install and you let the installation run from A to Z. After that, you will have Anaconda with all the bundle of all the softwares and packages on your computer, and you are ready to go. Okay, so let's start from the top. Now I have Anaconda installed on my computer. Let's see the simple things to view the whole bundle, and later on I will go into each main important thing that you need for your development of Python individually. So the first thing I will do is press start and search for Anaconda Navigator. The Anaconda Navigator could take a couple of seconds, and I heard about cases that it took about 2 minutes until it finally ran, but you can be patient with that, and then eventually it will pop up. And basically what it is a UI that enables you to see the whole installation of Anaconda on your computer. What do I mean by that? Okay, so this is the Anaconda Navigator. Now, what you see here at the Home tab is a collection of softwares that each and every software gives you specific capability. Now, I'm not going to be talking about all the things that we see here. I'm going to talk about the main things. And the main things are JupyterLab, Jupyter Notebook, Spyder, VS Code, which is Visual Studio Code, and RStudio. Okay, JupyterLab and Jupyter Notebook are basically two editors that run on your browser, which means, and we will see it later on, that once you run those servers that enables you to run code, it will pop up in your browser as a window, and we will see it later on. And you can write code in a very dynamic and very light and fast way, which will make your development kind of searchable and researchable friendly way. Okay, Spyder, which is an editor that gives you a specific window that you can write your code in. It's not that visual and not very friendly like the Jupyter Notebook, but it is very straightforward. You use it when you want to write code that you know that later on that's going to be your code that you're going to run in your production server. Visual Studio Code is another editor that enables you to run code. It's very similar to Spyder, but it has capabilities to connect to different sources of, if I want to run a code which is running on a Linux operating system on a server in the cloud, I can connect my Visual Studio Code into that server using an SSH connection and to debug all my code remotely. And I cannot do that with Spyder. Spyder is very limited in their regards. So if I want to do things like what I just mentioned, I will use Visual Studio Code. But if I want to do development in my own computer, in my own development server, I will use Spyder, but not necessarily. I mean, there are capabilities in Spyder that is developer friendly that you have in Visual Studio Code, but perhaps in the functionality of the editor, you as a developer will prefer Spyder versus the Visual Studio Code. That's totally up to you. And the final one is RStudio, which, mind you, that's the editor that I talked about when I talked about R, the programming language that I talked about when I talked about the alternative to Python is a programming language that data scientists or data analysts use. Now, this is the editor that you write R in, and you have an option to install it via Anaconda. Now, Visual Studio Code, Spyder, Jupyter Notebook, and JupyterLab, all of them are already installed, so you can launch them, okay? Now, let's start with Jupyter Notebook. Now, I'm gonna press launch, and then I will see, let's press launch. If I'll press launch, I'll go to my browser, and two things happened. The first thing that happened is that I got a command prompt that actually starts running on its own, and it's actually defining my computer as a server that the Jupyter Notebook is running over. Automatically, a tab with localhost on port 8889/3 is path to the Jupyter Notebook server. Now, what do we see here? Here we see the root directory, which is the directory that Anaconda is installed to. That is my root directory, and I can see Anaconda 3 here. Now, basically, this is the C/users/yossi of my computer. Basically, what you see here is the folder of my user on this Windows operating system. Now, here I can see all the folders that I have in that path. It's like if I go specifically to that path in my computer, I will see exactly the same thing. Here are all the folders, and here are all the folders, same folders. Here I have I removed the option of hide, and here Jupyter Notebook does not know that option. That's why you see here less folders than what you see in here in the window. But it shows me the same public folders. Now, in here, I can manage all my files, which are files that are not related to development and files that I decide that are relevant to development. Let's say that you never run Jupyter Notebook before and you want to run it. So you open up Jupyter Notebook, you see this page, and now you create a folder. You can call it any way you like. I call it Jupyter Notebook. And inside you will have all the code that you need in order to write your Python program. Now, I have several Jupyter Notebooks already here because I've been developing for a very long time. So I have different kind of softwares here for different use cases. But what we are going to do is we are going to start a new Jupyter Notebook. And what is a notebook? Well, let me show you what's a notebook. I press here on new, and then I have an option to open a new notebook with Python 3 as the language, programming language that's going to run in that notebook. So I press Python 3, and now a new notebook has been created. Now, let's see what we got here. We got a new window. It looks different from the window that we saw earlier. And here, there is a cursor which is flickering, which means that I can start writing code. Now, I'm just gonna show you, because you're new to Python, I'm just gonna show you a specific command in Python that all it does is just write into the screen whatever I write inside this parentheses. So what I just done is I wrote a command which name is print, which prints to the console, to the output, whatever I put inside here. And the brackets, that defines exactly what is the characters, what is the sentence or whatever it is that I want to write here, which has a specific name. We're going to talk about it in other sections of this course. And it prints it here. So what we see here is hello world. Now, as I run this command, a new cell has been opened. So that enables me to write commands and run them and manage them in different cells if I want to. For example, I can write here the same thing over and over again, and it's all in this cell. And because it's in this cell and not in the other cell, then when I run this cell, it will run only this cell and it will not affect the other cell. This is very research-friendly kind of way to write code, because in a different editor like Spyder, whenever I write code, I don't have an option to write code like that in different cells. We will get to Spyder in a couple of minutes, and then you will understand more firmly what exactly I mean. But for now, just try to see the functionality, which is very comfort-wise in Jupyter Notebook. It's a very segmentational way to write code in a very interactive way, because I can write code wherever I want, and if I want to take two different segments and put them together, I can do that, and I can delete cells. Now, the beauty here is not only that, but I can choose what is the type of the cell. That means that what am I writing in this cell? Am I writing a code, or am I writing different kind of code which is not Python? I can write HTML here. I can write something like that. I can write a headline like that. And now I have a headline for the code which is underneath the headline. I can write a whole description about what exactly is the code underneath here. This is a very visual way that you can mix together explanations for people who doesn't understand code and code together, so you can explain them what each code segment actually means and does. So if you want to visualize things that you write in your software and you want to show them to a business owner or someone who is not in the technical region, then you can do that easily with Jupyter Notebook. Now, I'm not going to cover all the ways that you can visualize things in Jupyter Notebook. That you can do that on your own when you research this tool, but it's a great tool. I will show you an example of how I can write a Jupyter Notebook, and I can write and add so many things that makes the notebook like this. This is a notebook that as segments decided exactly what each segment does. Segment is that cell. So you have here in this cell, if I double click it, you will see the code that generates this visualization. And mind you that it's in Markdown. Here, if I double click this, I will see this syntax, which is the way that you are writing the code. And I can see by the syntax that this is HTML. That means that I can mix together HTML and Python for different purposes, yet again, in the same notebook, which is way more comfortable way to show people whatever it is you're developing, or to teach someone, or to do a tutorial about what you want to teach someone regarding Python. So here we have an example of a notebook that mixed together explanations and code together, which is phenomenal. Now, this is an advantage. A disadvantage about Jupyter Notebook is that when I want to take this code, the Python code, which is what I'm interested in while when I'm trying to solve a problem, it is not that comfortable to take the whole notebook with all the HTML and all the additions and run it on a server, which is mainly, his main purpose is to run code in production. So this is a disadvantage, and we will see how Spyder is solving this disadvantage. But another thing about Jupyter Notebook, that you can press File and you can download the Jupyter Notebook in many kinds of formats. I mean, you can download it as a notebook, as is, which is a format of IPYNB. You can download it as a Python file, which actually cuts everything which is not Python code, and it turns it into one file that only has Python code in it, which is way suitable if you want to run this in production. That means that you want to run it on an actual server, so it will actually solve the problem that the code is meant to solve. And you can download it as HTML. That means that you can write code here, and you can download it as HTML, and then you can send this file to whoever you want. And the only thing that they need to have on their computers so they could see the notebook is a browser. Now, they will see the whole notebook, but they will not be able to run it, but they could see it if you will use it as an HTML. The same with PDF. You can download it as Markdown. You can download it as LaTeX, which is a language that academics use when they're trying to write their thesis. So another thing about Jupyter Notebook, that it has lots of shortcuts. If you'll press Escape and then you'll press H, which stands for help, you will see a lot of shortcuts that are built into Jupyter Notebook and that you can use. So don't hesitate, go through all of this cheat sheet and see exactly what are the shortcuts that are suitable to your use case. This is very, very handy, so use it. Okay, the JupyterLab, which I will not open, basically it is the little kid sister of Jupyter Notebook. They are almost completely the same, only Jupyter Notebook lacks specific features that Jupyter Hub has, which are a way to see the whole page of the folders and the files that you have in your root folder in a better way. And inside the notebook itself, the UI looks a little bit different, but on the basic, it's totally the same. Now, that doesn't mean that you don't need to use Jupyter Hub. If you want to, you can use it, and it's okay. The final result is the same if you will use Jupyter Hub or Jupyter Notebook. But for me, it's more comfortable to use the Jupyter Notebook because it's more stable. The Jupyter Hub is not that new anymore, but it is kind of new for me. It's not stable as I want it, but perhaps for you it would be okay. So don't hesitate and use it if you want. Now, there is another way to get inside a Jupyter Notebook, which is you can search for Jupyter Notebook, and then you will see it here. You press on it, the command prompt with the definition of your computer as a local server will run, and automatically this tab will open. Exactly the same way as we go through Jupyter Notebook and press launch. The difference is that you don't have to open the Anaconda Navigator to run the Jupyter Notebook when you go and use this method to run Jupyter Notebook by searching it, pressing it, and voila. Okay, let's see Spyder. Now, Spyder, again, is an editor, which is a software that enables you to write software, but it doesn't run on your server, on your browser. It's a desktop application that you can write code in and run it. Now, look at this. The editor is divided into several sections. The main section is the editor itself, which means that it's the place that you write your code in. Now, you can see the difference between Jupyter Notebook and Spyder in regards of places that you can write code in. In the Spyder, you have one big place that you can write code, and that's it. Now, that doesn't mean that if you have several lines of code, that you have to run all the code and not run specific lines of code if you want. I mean, the editor enables you to mark specific lines of code which are adjacent to one another and run exactly them. You can do that by pressing Control button if you have a Windows. And actually, if you have a Mac keyboard, you can press the Command or the Control. You can try either way. And then you press Enter, and it will run exactly the lines of code that are marked. Now, to the people that saw something on the lower right, you can see that something happened here, which brings me to the different section that I have in this Spyder software, which is the console area in this small triangle on the lower right. Now, what it is, it's a place that I can write code, and I don't have to put this code on the script in the editor. I can write code here and it will run. And look, it looks kind of like what we saw on the Jupyter Notebook here. So that's very similar in regards of writing code in cells. Like I can write something and it will run. So the main thing that I would do with the console is to test things that I'm not sure if they are suitable to be in the final code, which is in here, in the editor itself. So the console is a way that I can test things in my code. Now, in Jupyter Notebook or in Spyder, there's a definition of a kernel. And a kernel is basically defines a session, which is a period of time in which all the code that has been run in that period of time has memory and knows other codes that has run in that specific session. Now, because I ran something here in the editor, I will see it in the console. And if I will do anything in the console that is regarded to a specific thing in the code in the editor, it will affect it. I mean, those two different sections are independent of one another. So be careful with that when you're writing your code and you're running your tests. Now, if I want to restart a kernel, that means restart a session, I can press this and then I can press restart kernel and it will restart the whole session. And another thing I can do, I can run a different kernel, and every code that I will run in this kernel does not affect that kernel. But if this kernel is open on the console and I run this code on the editor, it will run in this specific kernel. So the code that will be run in the console from the editor depends on which console tab am I at that specific time. So another thing to notice and to be careful of, because that may affect your code. The third section is a section that combines different capabilities, but the main one, which is the most interesting, is the variable explorer, which let me see kind of different variables that I defined in my code. Now, we didn't talk about variables yet, but the important thing that I want you to understand about this concept is that I can see the variables that I have created in my code, which is something that I cannot do in Jupyter Notebook when I run code in cells. The only way that I can see the variable that I just created is by printing it into the output, which is basically the console in the Jupyter Notebook. So this is the main difference between Spyder and Jupyter Notebook, which is a disadvantage for Jupyter Notebook and an advantage for Spyder in regards of the comfort of seeing the variables that you have created in your program. So Spyder and Jupyter Notebook are the main editors that has been used in the Python community in the distribution of Anaconda. Mainly 95% of this whole course will be in Jupyter Notebook because of the comfort way that we can teach you how to program in the regards of Python for data analysis. So get familiar with it, play around with the things that I showed you, and I'll see you in the next section.